Hi everyone, for this video we're going to solve geometric sequence in series problems that are easy, basic to not so easy. So let's start with this one. Find the second term if the third term of a geometric sequence is -18 and the sixth term is 486. So let's write the given. So we have the third term, which is -18. We also have the sixth term, which is 486. And we're asked to find the second term. We don't know the first term and also the common ratio. We don't know that. So let's write this given from the formula that we know. Like if we need the third term, the formula is a sub 1 times r raised to n minus 1, where n is 3, right? So that would be a sub 3 is equal to a sub 1 r squared. And a sub 3 is equal to -18. So let's do the same thing with the sixth term. So that's a sub 6, is equal to a sub 1 times the common ratio, 6 minus 1, so to the fifth. And a sub 6 is equal to 486 is equal to a sub 1 r to the fifth. So as you can see with our equation, we can eliminate a sub 1 if we get the quotient of a sub 6 and a sub 3. So if we get a sub 6 over a sub 3, we'll have a sub 1 r to the fifth over a sub 1 r squared. Okay, let's substitute our given. A sub 6 is 486 over -18. So we can cancel a sub 1 and r to the fifth over r squared will be r raised to 5 minus 2 using the laws of exponent is equal to 486 divided by -18 is, so let's write that down first, 486 over -18. So r cubed is equal to -27. Therefore, r is equal to -3. So now that we know r is equal to -3, then we can get now a sub 2 by using this. A sub 3 is equal to a sub 2 r 3 minus 2 raised to 3 minus 2. A sub 3 is -18. A sub 2 r is -3 raised to 1. So divide both sides by -3. Okay, let's clear out some space. Okay, so this one, this is cancelled out. And -18 over -3 is positive 6. And that is our a sub 2. Second example, find the 11th term of the given sequence 2, 6, 18, and 54. So we are asked to find a sub 11. And we can find the common ratio by getting the quotient of second term over the first term, which is 3. And let's check if that's also equal to the third term over the second term. So common ratio is 3. So let's substitute from our formula. A sub 11 in finding the nth term is equal to a sub 1 r raised to n minus 1. So a sub 11 is equal to the first term is 2 times common ratio is 3 raised to 11 minus 1, and that is 10. So let's use our calculator to get what is 3 to the 10th power times 2. So 3 to the 10th power is 59,049. So multiply this by 2. The answer is 118,098. So that's our 11th term. Next problem, find the sum of the 7 terms if the first term is negative 2 and the common ratio is negative 3. So we need to get S7. First term is given negative 2. Common ratio is negative 3. So using the formula, a sub 1, okay, let's rewrite that. So S sub 7 would be a sub 1 times 1 minus r raised to the nth over 1 minus r. So let's substitute our given. A sub 1 is negative 2. 1 minus common ratio is negative 3. I'll make sure I enclose that in the parentheses. Raised to the nth or 7th power over 1 minus negative 3. So negative 2, 1 minus negative 3 raised to the 7th power is negative 2,187 all over 1 minus 3, so that will be 1 plus 3. So S sub 7 is equal to negative 2, 1 plus 2,187 over 4. So let's cancel this. This will be 2. So we have negative 1 plus 2,187 is 2,188 over 2. So the sum of the first 7 terms is negative 1,094. Example number 5. Find the sum of the infinite series negative 5, negative 5 thirds, negative 5 over 9, negative 5 over 27, and so on and so forth. Let's say, for example, the word infinite is not mentioned. So how do we know which formula to use, whether if it's the finite formula or the infinite formula? So we can do that by getting the common ratio, because we know if the common ratio or the absolute value of the common ratio is greater than 1, it diverges. So we cannot use the infinite series formula for getting the sum. Okay, so it needs to be less than 1 or the series converges. So let's find. So negative 5 over thirds over negative 5. So multiply both sides by 3. So we'll have 5 over 15, or we have 1/3. So since our R common ratio is less than 1, so we can use the infinite series formula. So that is a sub 1 over 1 minus R. So our a sub 1 is -5. 1 minus common ratio is 1/3. So -5 over, let's make 3 over 3 R1 minus 1/3. So we have -5 over 2/3. And then multiply both our numerator and denominator by the reciprocal of 2/3. So we can cancel that out. So we have -5 times 3/2. So S infinite is equal to -15 over 2. Our last problem. Insert 3 geometric means between 3 and 1875. So the formula for geometric means is the square root between two numbers. So if we get 3 and 1875, we will get this term. So let's do that. So 3 times 1875 is equal to the square root of 5625. And the square root of that is 75. So we have 75. Now we can find this because we know 3 and 75. So 3 times 75 is equal to square root of 225, and square root of 225 is 15. So now this is 15. Now we can get this from getting the square root of 75 times 1875. Let's use a calculator. It's the square root of 140,625. So the square root of that is 375. So therefore, the 3 geometric means between 3 and 1875 is 15, 75, and 375.